Welcome, everyone. Ready to dive into something massive.
I'm ready. Let's do it.
Today, we're tackling the BAO Great Wall.
Ah, yes. A mind-boggling structure.
To get a handle on it, we've got scientific articles, encyclopedia entries, and even some science news reports.
A good mix should give us a well-rounded view.
Our goal: to help you understand just how big, how significant this thing is, and maybe touch on the debates about it, all in a short, STEM-focused way.
Perfect for our listeners.
So first off, just how big are we talking?
Okay, imagine our Milky Way, right? Now multiply that by 10,000.
10,000 Milky Ways, geez.
That's the BAO Great Wall stretching 1 billion light years across.
1 billion. So even at the speed of light, it'd take 1 billion years to cross it.
That's the scale we're dealing with. It's truly one of the largest known structures in the observable universe.
It's hard to even picture that. So if it's that big, what exactly is it? Like, what's it made of?
Think of it like a cosmic web. You've got filaments of hot gas, galaxies all clustered together.
Right, I've heard of those, like the cosmic web.
The BAO Great Wall is part of that, yeah. Over 830 galaxies arranged into 4 superclusters, all connected by those filaments.
So it's like a giant honeycomb structure across the universe.
In a way, yeah. And to be precise, for our STEM folks, those superclusters measure 186 echo of MPC, 173 AU MPC, 91 hour MPC, and 64 up MPC.
Those are some serious dimensions. Okay, but before we get too lost in the size of it all, the name BAMSS
Kitschy. Right.
stands for Baryon Oscillation Spectroscopic Survey.
And mouthful, I know.
More than just a name, though. It's a whole project, right? And this project is how they found this huge wall.
Exactly. BAO was designed to map the early universe. It does this by looking at something called baryon acoustic oscillations, or BAOs.
BAOs, okay. Those sound familiar, vaguely. Refresh my memory.
So picture the Big Bang, that initial explosion. In those first moments, sound waves rippled outward.
Like ripples in a pond after you throw a rock in.
Perfect analogy. And those ripples, they created specific patterns in how matter is spread out.
So these BAOs are like echoes of the Big Bang, still detectable after billions of years.
Exactly. And the way galaxies are clustered, that shows us those patterns. BAO acts like a cosmic ruler, measuring distances across the universe, mapping it all out.
And that's how they found the BAO Great Wall, by seeing these ancient sound wave patterns. Incredible. But I've heard there's debate, right, about whether it even is one structure.
Ah, yes. Not everyone agrees with that classification.
Why is that? What are they arguing about?
Well, some astronomers question if all those parts, the superclusters and filaments, are truly moving together. Like, are they a unified whole or just drifting apart slowly because of the universe expanding?
So, like, how do we even define a structure if everything's moving apart anyway?
That's a key question they're grappling with. Plus, the BAO Great Wall has a weird shape, lots of kinks and bends.
Doesn't sound very wall-like then. So what are the main arguments on each side of this debate? I'm curious to hear what evidence they have.
Well, on one hand, you can see a clear connection between the superclusters in the BAO Great Wall. They're linked by those filaments, the gas and galaxies. So that suggests a structure, right?
But what if they're moving apart, like slowly drifting because the universe is expanding? Does it still count as one thing then?
That's the heart of the argument. Some astronomers say a real cosmic structure has to be bound by gravity, like its parts are pulling towards each other, stronger than the expansion.
Makes sense. But others disagree.
Yeah, others think the definition can be looser. Like, even if they're drifting apart, if they're interconnected, it's still a structure.
Huh. So the BAO Great Wall is kind of pushing the limits of what we know about structures in the universe, like making us question our definitions.
Exactly. And it shows how dynamic these things are. It's not just a static wall sitting there. It's being influenced by all these forces.
Speaking of forces, what about the expansion itself? How's that affecting something as big as the BAO Great Wall?
Well, that's where dark energy comes into play. This mysterious force that's actually accelerating the expansion, working against gravity.
So dark energy's pushing everything apart, even within the BAO Great Wall.
Yeah.
Could it be stretching it or even tearing it apart over time?
It's definitely possible. Some of those kinks and bends we talked about could be evidence of this cosmic tug of war, gravity trying to hold it together, dark energy pulling it apart.
Wow. So as we're admiring this huge structure, it could be slowly dissolving. Kind of makes you think.
Slowly on a cosmic scale, of course. We're talking billions of years. But it highlights that the universe isn't static. It's constantly evolving, forces interacting on a grand scale. The BAO Great Wall is just one snapshot of that.
A snapshot that's giving us a lot to ponder. Okay, let's back up a bit. How do they even find this thing? I mean, finding something that massive in space.
That's where the Baryon Oscillation Spectroscopic Survey, BISS, really comes in. Remember those BAO imprints?
Yet echoes of the Big Bang.
Right. By analyzing how galaxies are distributed, BAOS could detect those imprints. They act like markers showing the underlying structure of the universe. And that's how they found the BAOS Great Wall.
So it's not just seeing galaxies, it's understanding the pattern of them, which tells a story about the universe's evolution. That's pretty amazing.
Yeah.
Okay, as we wrap up thinking about the BAOS Great Wall, what are the key takeaways for our listeners?
I'd say the BAOS Great Wall shows how powerful our observation techniques are becoming. And it shows we're still trying to understand the universe's structure on these huge scales. It challenges us to think about what a cosmic structure, even IS, and shows how gravity and dark energy are shaping these massive objects.
Definitely makes you feel small thinking about all that. But also exciting, right? So much more to learn out there.
Absolutely. And that's what keeps us exploring.
We've talked a lot about the size, the structure, the debate about the BAOS Great Wall. But there's something we haven't touched on much.
What's that?
The human element. It's easy to get lost in the immensity of it all, the billions of light years, the complex forces. But we're the ones comprehending this stuff.
It is pretty remarkable, isn't it?
Like we humans developed the tools, the math, the theories to look out into space and understand these structures that are so far away, so ancient.
It speaks to that fundamental human curiosity, the drive to explore, to understand our place in the cosmos. It all starts with looking up at the night sky and wondering.
And the BISS Great Wall is a pretty amazing thing to wonder about. Shows us how much is still out there to discover. Makes you realize how much we don't know yet.
Humbling, for sure. This massive structure, one tiny piece of a much larger cosmic puzzle. And who knows what other wonders are still hidden out there.
Makes you want to keep searching.
Hmm.
Speaking of which, what are some of the big questions scientists are still trying to answer about the BISS Great Wall?
Well, like we discussed, its classification is still a big one. Is it truly one structure or multiple things drifting apart? We need more observations, more data to figure that out.
And what about dark matter, dark energy? We know they play a role, but how exactly?
The BISS Great Wall is a great way to study that. By analyzing the galaxies within it, seeing how it changes over time, we can learn more about how dark matter and dark energy behave, how they shape the universe.
So it's not just a cool thing to look at, it's a tool to help us solve some of the biggest mysteries in cosmology.
Exactly. It's a cosmic laboratory of sorts.
Well, it's been fascinating diving into this with you today. I think we've covered a lot of ground. Any final thoughts for our listeners before we wrap up?
I'd say remember that the universe is full of surprises. There's always something new to discover, something that challenges our understanding. And it's that sense of wonder that drives us forward, keeps us exploring.
I like that. The universe is vast and full of awe-inspiring things like the BISS Great Wall, and we're constantly learning more. And anyone can be a part of that journey of discovery.
Absolutely. Whether you're a scientist or just someone who enjoys learning about space, there's always something new to explore.
Yeah, couldn't have said it better myself. Well, that brings us to the end of our deep dive into the BOS Great Wall. Thank you all for joining us, and keep looking up.